Hello everyone and welcome to Sally in Bytes. Today, I am here to teach Relational Database and SQL, Part 2, DBMS Models, Hierarchical Data Model, Network Data Model, Relational Data Model, their advantages, limitations, and the difference between the three models for the Class 12 students of computer science. So, let's dive in and get started. Let's learn about DBMS models. So, what's a data model? Data models are conceptual tools, like blueprints, for databases, outlining how data is structured. They define data types, what kinds of data can be stored. Relationships, how data elements are connected. Constraints, rules for data integrity and organization. Characteristics of a good data model. Data models are ideally represented through visual means, employing diagrams and symbols for clear and intuitive communication. In a data model, data representation should be free from any unnecessary duplication or repetition, ensuring a clean and efficient structure. A data model should be accessible and easily shareable among multiple applications. The data in a model should always be dependable, steady, and correct in every way. Let's discuss about the types or classification of data models. Data models are classified as object-based data models, record-based data models, and physical data models. Record-based data models are classified into hierarchical model, tree structures, network model, directed graphs, and relational model, files or tables or relations. Let's see the record-based data models one by one. Let's learn about the hierarchical model, tree structures. Key points about a hierarchical data model. Tree structure. In a hierarchical model, data records are organized in a tree-like structure rather than a graph. It resembles an upside-down tree. Hierarchy representation. This model represents a clear hierarchy, where each data element is a part of a parent-child relationship. Each element in the hierarchy has a specific parent except for the top-level element. One-to-many relationships. The hierarchical model typically depicts one-to-many, 1:m relationships, where a parent segment can have multiple child segments. This allows for the representation of complex and multi-level data relationships. One parent, many children. In this model, each parent segment can have multiple child segments, but each child segment can only have one parent. This enforces a strict, one-way relationship from parent to child. We can see the hierarchical model, tree structures, here. We can see that the student database contains various files like library file, fees file, and exam file, related to a student. In this kind of arrangement, a file higher in the hierarchy is known as parent of the files contained inside it. We can see the parent file on the top level. Here, student is a parent of the library, fees, and exam files respectively. Thus, this model represents a one-to-many relationship between a parent and its children in the form of a hierarchical, upside-down, tree. Advantages of hierarchical model, tree structures. Simplicity. This model is easy to understand and use due to its straightforward design. Enhanced data sharing. It encourages the sharing of data among different branches of the hierarchy. Data integrity. The parent-child relationship ensures that data remains consistent and maintains its accuracy. Efficiency and scalability. It's an efficient system that naturally accommodates one-to-many, 1:m relationships, making it ideal for handling diverse connections and expanding datasets. Limitations of hierarchical model, tree structures. Inflexibility for non-hierarchical data. This model works well only with hierarchical relationships, making it inflexible for mapping non-hierarchical connections. Complex implementation. Building this structure is complicated and resource-intensive because it relies on using pointers from a parent to its children, which demands additional memory space. Parent mode dependency. The entire model is heavily reliant on the root node, parent node. Deleting the root node can result in the deletion of all child nodes and, consequently, the entire structure. Application update. Changes in the structure require changes in all the applications. Examples of hierarchical model, tree structures. Both IBM's IMS, Information Management System, and System 2000 utilize hierarchical models with tree structures for data organization and management. Let's learn about network model, directed graphs. Key points about the network model. Flexible representation. The network model is a database model that provides flexibility in representing objects and their relationships. Records and links. It consists of records connected to each other through links, creating a network-like structure. Replacing hierarchy. Unlike the hierarchical model, it replaces a rigid hierarchy with a more versatile graph-based structure. Many-to-many relationships. One of its significant features is the ability to handle many-to-many, M-is-to-M, relationships, where a child can have multiple parents. We can see the network model here. It is clear that this model represents many-to-many relationships. It can be observed that the file exam is associated with three tables: library, fees, and student. Thus, this model shows that a child can have more than one parent. This model is an improved version of hierarchical model which we have seen before, having records along with pointers. These pointers establish many-to-many relationships and are termed as links. Each record has its respective pointer or link with which it is associated. We can see the red double-headed arrows here called links. It consists of all the files, student, library, exam, and fees are connected to each other through links, creating a network-like structure. Advantages of network model, directed graphs. Handles complex relationships, supports many-to-many, M-is-to-M, multi-parent relationships, making it suitable for modeling complex data connections. Flexible data access. Provides easy and flexible data access, enabling efficient retrieval and manipulation of data. DDL and DML. Includes both data definition language, DDL, and data manipulation language, DML, allowing for data definition and data manipulation within the model. Enhanced data integrity. Promotes better data integrity by enforcing referential integrity constraints and minimizing data redundancy through the use of pointers or links between records. Limitations of network model, directed graphs. Complex structure. The model is structurally complicated due to numerous links, which can hinder efficiency and increase the complexity of data management. Application program changes. Structural changes require changes to be made in all application programs. High-level language requirement. A high-level language interface is required to interact with the database. Increased memory usage. The model consumes additional memory to store links or pointers. Examples of network model, directed graphs. UNIVAC's DMS 1100 and IDMS, Integrated Database Management System, are examples of network database management system. Next, we are going to learn about the most popular data model in DBMS is the relational model, files or tables or relations. Popularity. The relational model is the most popular data model in database management systems, DBMS. Scientific and stable. It is considered more scientific and stable compared to hierarchical or network models due to the absence of pointers. Pointer-free. Unlike other models, it doesn't use pointers in record relationships, reducing the risk of inconsistency and improving data integrity. Two-dimensional tables. Data is organized into two-dimensional tables known as relations. These tables are the foundation of the model. Interrelation. Tables or relations are related to each other, allowing for efficient data retrieval and management. EF-COD's contribution. The relational model was developed by EF-COD and serves as the basis for relational databases. Table structure. Each table contains logically related records with the same fields, making it easy to manage and query data. Data persistence. The contents of a table can be permanently saved for future use, ensuring data durability. Simplicity and efficiency. The relational model is simple and efficient, providing the necessary properties and capabilities for processing data with storage efficiency. Let's learn about relational model, files or tables or relations. A relational model is like a big collection of tables, and each table has its own special name. This model organizes the database by using these tables or relations. Let's see the characteristics of relational database. Structured data. Data is organized in a structured way, resembling rows and columns in what's called a relation. You can see in this picture, a table named student with field name, roll number, name, age, and marks are given. Here rows which are marked in red boxes represent records or tuples. Example, if you want Alice record. Then, roll number is 1001, name Alice, age 16 and marks 92. Next is the columns marked in blue boxes, also known as fields or attributes. Are roll number, name, age, and marks columns. And finally the table marked in yellow box is also called a relation. The next characteristics is the tabular representation. Each relation is represented as a table or file, making it easy to understand and work with. Here student is the table name. Next is the attributes. The columns in a table describe the field or attributes of an entity being modeled, such as a person or product. Entity rows. Every row in a table represents a single entity, like a specific person or item. Rows are represented as tuples or records. Scalar values. Each cell in the table holds only one value or data. It's simple and not a mix of multiple things. Operations on entire relations. All operations are performed on the whole relation or table, and the result is also a complete table. Relational data model represents many-to-many relationships which can be established using primary and foreign keys. Primary and foreign keys will be discussed in the next video, Relational Database and SQL Part 3. Advantages of relational model. Structural independence. A relational model provides structural independence by using independent tables. Data consistency. Modifications to the table structure do not affect the data access or other application programs. Tabular representation. Data is presented in a tabular format, making it easily comprehensible and straightforward for users to understand. Database design ease. The tabular view simplifies the database design process, making it user-friendly for creation, utilization, implementation, and management. SQL support. Relational Database Management Systems, RDBMS, offer built-in support for structured query language, SQL, facilitating powerful and standardized data querying. Flexible data handling. Data organization and manipulation is easy, flexible, and faster. Abstraction of complexity. RDBMS systems have strong tools for organizing data and making it work efficiently. These tools hide the technical details of how data is stored, making it easier for people to use and manage the database. Mathematical operations. RDBMS systems enable successful execution of mathematical operations on data, expanding their utility beyond mere data storage and retrieval. Limitations of relational model. Hardware and software overheads. RDBMS systems can impose additional demands on hardware and system software, potentially requiring more computational resources, which may increase costs and complexity. Database size. As data accumulates, relational databases can become quite large, which can lead to challenges in terms of storage, performance, and maintenance. Let's see the difference between hierarchical data model, network data model, and relational data model. First point is the data structure. Hierarchical data model is a hierarchical structure with a single root and child nodes. Child nodes are organized in a tree-like fashion. Network model is a graph-like structure with nodes and edges. Nodes can have multiple parent and child nodes. Relational data model is a tabular structure with rows and columns. Data is organized in tables, and each table represents an entity. Second point is the relationships. Hierarchical data model. Parent-child relationships. Each child has exactly one parent. Network data model. Many-to-many relationships. A node can have multiple parents and children. Relational data model. Many-to-many relationships can be established using primary and foreign keys. Third point is the flexibility. Hierarchical data model, limited flexibility. It enforces a strict hierarchical structure. Network data model. More flexible than hierarchical, but less so than relational. Supports various relationships, but not as versatile as relational. Relational data model. Highly flexible. Can represent a wide range of data structures and relationships. The fourth point is the schema. Schema in DBMS is the design of a database that describes how data is organized and related. Hierarchical data model, schema is closely tied to the hierarchical structure. It's implicit in the organization of nodes. Network data model. Schema can be more explicit but is still somewhat tied to the graph structure. Relational data model. Explicitly defined schema with tables, columns, and keys. Fifth point is data integrity. Hierarchical data model. Enforces data integrity through hierarchical relationships. Network data model. Data integrity is maintained, but it can be complex due to multiple relationships. Relational data model. Data integrity is maintained through primary and foreign key constraints and normalization. Sixth point is the scalability. Hierarchical data model. May be less scalable for certain data access patterns. Network data model. Scalability depends on the specific implementation. Relational data model. Relational databases are well established and can scale efficiently. Seventh point is the atomicity. Hierarchical data model. Operations are often atomic at the node or edge level. Network data model. Atomicity depends on the specific implementation. Relational data model. Supports atomicity at the transaction level. Eighth point is querying. Hierarchical data model. Typically uses specialized query languages, for example, XML query languages. Network data model. Specialized query languages or extensions to query graph structures. Relational data model. Standardized query language, SQL, structured query language, is used for querying. Ninth point is use cases. Hierarchical data model. Suitable for data with a clear hierarchical structure, such as file systems and XML data. Network data model. Suitable for data with complex relationships, such as network data and some specialized applications. Relational data model. Versatile and suitable for a wide range of data types and applications. 10th point is historical significance. Hierarchical data model. Historically used in older database systems and specific applications. Network data model. Historically used in some database systems and niche applications. Relational data model. Widely adopted and used in many modern applications and systems. Thanks for watching. Please subscribe if you are new to my Sally and Bytes YouTube channel to stay updated with engaging content and never miss out on my latest videos. If you like this video, don't forget to give this video a thumbs up. Share this video with your friends and let computer knowledge reach every corner. Watch the upcoming videos, Relational Database and SQL, Part 3, Relational Database. Database keys. Primary key, candidate key, alternate key, foreign key. You can check the link in the description box given below.